Morning. This is a short video on our Unit 3, Topic 2, Midterm Review. So let's get started right away. When I look at this graph, I can see that it's starting at the midline and it goes down to the min rather than up to the max. It has that S shape, so I know it's negative sign. So I automatically put that into my memory box that since I'm going down rather than up to the max, this is going to be a negative sign. So one of my transformations is going to be that it is reflected. It's reflected from the parent. My amplitude is counted from the midline. If you look carefully at the y-axis, I'm counting by twos. This graph is shifted up. I always look for the midline first. I can see that the midline is at 3. One way to tell is by counting all the units between the max and the min, and then dividing by 2. You can see that calculation right here. Or you can just find the middle of the graph like I've taught you. The middle of the graph is at y equals 3. Remember, your answer must be a y equals. And then counting from 3, if I go up to 7, that means my amplitude is 4. I confirm that by going down from the midline to the min. My period is from 0 as the x value all the way to where the S curve stops. That's at 2 pi. Now, the next question is odd, even, neither. If you look at this graph from here to here with the center point at the origin, you can see that this is actually an odd graph. This is an odd graph because it has that origin. It says neither, but I'm pretty sure it's odd. Oh, no. Good morning. This is a review video for the Unit 3, Topic 2, Midterm. We're going to start with Part 1, Number 1. When I look at this graph, I can see that it is a reflected sine curve because rather than go to the max after the midline, we go to the min. There's your sideways S. I also notice that the max is at 7. The min is at -1. One formula you can use to find the midline, if you're not going to count the number of units between 7 and -1, is the maximum number plus the minimum number divided by 2. And then we're going to get 3 as the answer. So that's going to be our midline. Our midline always must be as an equation of a line, y equals 3. Our amplitude comes from counting from the midline to the top. That is going to be 4 spaces. There's also another formula for finding the amplitude. That's max minus min divided by 2. You have to be really careful when you use the amplitude versus the midline formula. So that confirms that my answer for the amplitude is 4. For the period, I'm looking from the y-axis to where the S stops. The S stops at 2 pi. So 2 pi is your period. For odd, even, neither, this point here on the y-axis is not at the origin. And when I look over the y-axis, it's not a reflection. That means that this graph has neither symmetry. Our transformations to talk about, the first thing is reflection. The second thing is translation. And the third thing is vertical dilation. All of those can be described using the answers that we gave in number 1. From the parent, there is a vertical dilation of 4. That is from the amplitude. There is a translation. I require you to put the word translation before you say up 3. And the other thing that should say here but doesn't say is that it's also a reflection over the x-axis. Number 2, same thing. Find your midline, possibly using your formula max plus min divided by 2, or by counting from the maximum to the min, and then dividing that by 2 to figure out what the amplitude is. So I can see from the graph and my formula that my midline is 1. My period goes from the the y-axis all the way until I complete the curve. Remember, this is a cosine curve, so if my curve looks like this, it's a negative cosine curve, but its length is pi, so our period is pi. Counting either from the midline or using our formula of max minus min divided by 2, we can see that our amplitude is going to be 3. As for odd, even, neither, cosine graphs are generally even graphs because they reflect over the y-axis. I can see this U shape from here to here reflecting over the y-axis. That means it's an even graph. In terms of our transformation, it's reflected because the U shape is turned upside down. The amplitude is 3, so that's the vertical dilation. And because our midline is 1, it's translation up 1. Remember, these transformations in the video, they're not including the reflection. There is a reflection. This curve is a little easier for number 3 because it's a right-sided cosine curve that stops at 4 pi. Remember, this distance from the y-axis to the end of the U shape, that is your period. 4 pi, your midline did not change. Your midline is still at 0 because your amplitude is 2. So 2 up from 0 is 2, 2 down, that's the max. 2 down from 0 is -2, that's your min. And so our midline is 0 and our amplitude is 2. Cosine curves are generally even. If I look at this cosine curve, this part here over the y-axis, I can see the mirror shape. This is even. Transformations. There is no translation up or down. There is a stretch of vertical dilation of 2. That is the only transformation. Second page, same thing. I'm doing you can see from number 4 that the midline has changed. It's translated up to 5. How do I know it's 5? Because the y-axis is counting by 2. So for me, I'm going to start at the midline of 5, and I'm going to count up towards the max. I can see that that's going to be 3 units. So that's going to be our amplitude. Our period goes from the y-axis to where it goes back to the midline again. Look at this graph. Starts at y, goes to the min, goes back to the midline, max, and then mid. That's a sine curve that is reflected. And if I look at where this graph starts, well, first let's do the period. The period ends at 2 pi. That's from the y-axis to the end of the S curve. So our period is 2 pi. And then in terms of our symmetry, it is not a cosine, so it's unlikely to be even. And it's not starting at a midline at the origin or the x-axis. So this is another one that has neither symmetry. For our transformations, our graph moved up 5, translation up 5, and it's a reflection over the x-axis. What is the formula for converting radians to degrees? Remember, degrees does not have pi in it, so it has to be 180 over pi. For number 2, the formula to convert from degrees to radians, you want to get pi into your answer, so that's pi over 180. These are the only 2 formulas you need for converting. Now, how do we do conversions? If I have 3 pi over 2, and I'm converting from radians to degrees, that means it's 180 over pi. Why? Because I want bye-bye, Miss American Pie. I want those pi's to divide to 1 and cancel out. That only leaves 180 divided by 2 to put in your calculator. That answer is, 3 times 180 divided by 2. Where did the 3 come from? It came from here. Times 180 divided by 2. That's the only thing that goes in your calculator to make 270. Again, in the second one, 3b, you are dividing out the pi's to be 1. You're left with 5 times 180 divided by 4. That is the only thing that goes into your calculator. Answer, 225 degrees. Do not forget the degree symbol. Number 4, when you're going from degrees to radians, now you're multiplying by pi over 180. Remember, pi doesn't go anywhere except in the answer. 135 divided by 180 in your calculator makes 3 over 4 when you make it a fraction. Do not leave it as a decimal, and do not forget to put pi in your final answer. 230 times pi over 180, 230 divided by 180 goes in your calculator. The decimal turned to a fraction. Don't forget to put pi in your answer. Now for these, you are given an equation. I highlighted it in purple. And then you're starting to diagnose right away. I would start diagnosing right away with the transformations. The transformations show an amplitude of 3. So that's going to be a vertical stretch of 3. There's a negative in front of the equation. That's reflection over the x-axis. Plus 4 moves the midline and the entire graph. So that is a translation up of 4. That's our transformations. For our amplitude, remember to give the 3 as a positive number. The negative is not part of the amplitude. Our period goes from the y-axis until this upside down cosine curve ends. It ends at 2 pi. That makes our period 2 pi. Our midline is going to be the halfway between the curve, between the max of, it looks like 5. No, sorry, it's 4, 1, 2, 3. So we've moved our midline to 4. That comes from the equation, the plus 4. We already talked about the period being 2 pi, and we already talked about the transformation. Next page. Cosine x minus 4. So that means the only thing that's happening is our graph is moving down 4 units. In terms of our transformation, it's translation down 4. Our amplitude, since it did not change from the parent, there's no number in front of cosine. That means that our amplitude stays at 1. Our period goes from the y-axis, the max to the max. Again, my period is 2 pi. My midline comes from the minus 4. Make sure it's an equation. Y equals negative 4. Next equation, 4 sine x plus 2. Plus 2 is going to be our midline, so y equals 2. 4 is our amplitude. Period goes from the y-axis, in this case, midline, past one midline to another midline, sine curve that is right side up, ends at 2 pi. That's going to be our period. Transformations looks like a vertical stretch of 4 from the amplitude and a translation up 2. Last page. Negative 3 sine x plus 5. Plus 5 always tells us what our midline is. So that's y equals 5. You're going to draw that doing the y-axis yourself. You're going to number this yourself. The 3 tells you to go up from 5 to make 8 for the max. Go down from 5. 5 minus 3 is 2. That's your min. And then I taught you to sing the song when you graph this. The song goes, since it's a negative sign, rather than go mid max, you're going mid, min, mid, max, mid. And then you're going to connect your points to make a nice curve in the right places. You have to do probably 2 periods of this, so you'll have to go backwards in the same sing-song pattern. From the equation, amplitude 3, the period went from the y-axis to 2 pi, so it's 2 pi long. We already talked about our midline. Our transformations are +5 means translation up 5. The negative in front means reflection over the x-axis. The 3 for the amplitude means vertical dilation of 3. Last ones. This is the hardest for you. So I'm just going to reveal the answers and talk about it. First of all, you must rewrite this equation this way. And then they give you a number to put in for sine. In this case, it's negative square root of 5 over 4. You square that. When you square that and make it a fraction in your calculator, you must show this step where you subtract 5 over 16 from both sides. It's still an equation. You still need an equal sign. Your cosine is squared, and this is only asking for cosine theta. That means square rooting both sides. The bottom can be square rooted. That is 16, the square root is 4. The top cannot be square rooted, so you leave it that way. Now, your answer is either positive or negative, depending on the quadrant. Since we're asking for cosine, and cosine is based on x, cosine in quadrant 4, x is on the right side of the y-axis. That means our answer is going to be a positive square root of 11 over 4 for cosine theta. Make sure you end with cosine theta equals square root of 11 over 4. Same thing for the last problem. They're giving you a value for cosine. You're going to plug it into your equation and square it. It's still added to sine theta squared equals 1. In equation form, you're going to subtract that from both sides. Once you do 1 minus in parentheses 3 over 25, you're going to square root both sides. Square rooting sine squared theta leaves just sine theta. And in your calculator, if it is 22 over 25, only 25 is square rootable. So that's going to leave 5. It's plus minus until you figure out what quadrant it is. This time you're trying to find sine. Sine is based on y. Y is negative in quadrant 4. So your final answer is negative square root of 22 over 5 for sine theta.